These problems have to do with finding the slope of a line that's tangent to the graph of a function. And that is one of the definitions of the derivative. If you take the derivative of a function, whatever value you plug in for x into that derivative gives you the slope of the line tangent to this function at that point. So in this first problem here, find the slope of the line tangent to the graph of 4 times the square root of 4x plus 2 at x equals 4. All we have to do is find the derivative of this function, then plug in 4 for x. That will give us the slope of our tangent line. So let's go ahead and do that. I'm going to rewrite this with a fractional exponent instead of the square root, because I think it's easier to apply the power rule that way, or at least easier to see how it works. So this is 4 times 4x plus 2 to the 1/2. Same thing. I just rewrote it. Now let's take the derivative here. We're going to need to use the chain rule, so I'm going to call this inside chunk 4x plus 2. I'm going to call that u. And du then, the derivative of this, is just 4. And this problem then becomes 4 times u to the 1/2. And then because this is the chain rule, we need to remember to multiply du. Let's go ahead and apply the power rule here. So this 1/2 gets multiplied by the 4, so that becomes a 2. And then the power gets decreased by 1, so this is u to the negative 1/2. And then multiplied by du, so multiplied by 4. So this is, well, 2 times 4 is 8, so this is 8. And u to the 1/2 would be, or u to the negative 1/2 would be u to the 1/2 down here on the bottom of a fraction. And now we can go ahead and plug back in our u value. U is 4x plus 2, so this really comes out to be 8 over the square root of 4x plus 2. So that's our derivative. This is f prime of x. Now to find the slope of the line tangent to this function at x equals 4, we simply plug in 4 for x. So we get 8 over 4 times 4 is 16 plus 2, so that's the square root of 18. And then we'll probably want to rationalize this, so I'm going to multiply by the square root of 18 over the square root of 18. And we get 8 times the square root of 18 over 18. And let's see, I can take 9 out of here, so that's 24 over 18 times the square root of 2. And 24 over 18, I think what we get here is 4/3 times the square root of 2. That is the slope of the line tangent to this graph, our original function, at x equals 4. All right, let's try another one. This one says, find the x values of all points where the curve of this function here, has a horizontal tangent. So if something has a horizontal tangent, what does that mean? Well, let's put some fake function up here. At this point right here, there's the horizontal tangent. And what that means is the slope of a horizontal line, this slope right here, is 0. So if we want to find out all the points where any function has a horizontal tangent, we can find out where the slope of a tangent line equals 0, which means we take the derivative of that function and set it equal to 0 and solve for those x values. So let's try that. I'm going to take the derivative of this function here. So y prime equals, that'd be 3 times 9 is 27, x squared. And 2 times 6 is 12x and minus 15. And now we're going to set that equal to 0. And I think I'm going to pull a 3 out of this to start with. 9x squared plus 4x minus 5. And let's see, I think it looks like we're going to need to use the quadratic formula to get this one done. So that would be negative 4 plus or minus the square root of 16 minus 4ac, so that's actually going to be plus 180, all over 2a, so it's all over 18. All right, 16 and 180 adds up to 196. That's nice because that's the square of 14. So this really becomes negative 4 plus or minus 14 over 18. And negative 4 minus 14, that would be negative 18 over 18. So negative 1 is one of our solutions. and let's see, I think the other one comes out to be 10/18, 5/9. So those are the two x-coordinates of the points where the tangent to the graph is horizontal, or the slope is 0. And we've answered that problem. Let's try one more. All right, this one's just slightly more involved. It asks us to write an equation for the tangent line to this graph, this function, at x equals -2. Now, to write an equation for a line, I think the best way to approach this is to use the slope point form, or the point slope form. For this form, you need a point and you need the slope, and then you fill in y minus y1, that's the y-coordinate of the point, equals m, that's the slope, times x minus x1, that's the x-coordinate of the point. So all we have to do is find the point and get a slope. Now the slope we know how to get. At x equals 2, the slope of the tangent line is the derivative of this, evaluated at -2. So let's take the derivative of this first to get our slope. So 2x, that's just going to be 2, and I'm going to rewrite this as 2x plus 3 times x to the -1, so we can apply the power rule a little more clearly. We take -1 and multiply it by the 3, so we're going to get -3, and we subtract 1, so -1 minus 1 is -2, so this is times x to the -2, or we could rewrite it like this. Our derivative is 2 minus 3 over x squared. Now if we plug in -2 here, we get 2 minus 3/4, which equals 5/4. And that is our slope. Now we need our point, and the point is really very easy too. We are told this is at the value x equals -2. To get the y for that point, this is already our x-coordinate. We just plug this in and evaluate the function. So I'm going to plug in -2 here and here, and that gives me 2 times -2 plus 3 over -2, and that is -4 minus 3/2, which is -11/2. So now we have our point. Our point is -2, comma -11/2. We'll plug that in to the point slope form. So y minus a -11/2 would be plus 11/2. The slope is 5/4, that's our m value. And this is x minus a -2, so x plus 2. I'll distribute the 5/4 here. And then I'm going to change this 11/2 into fourths. So that's 22/4. And then we just have to subtract 22/4 from both sides. Oops. And you get y equals 5/4 x. And let's see, that's -12/4, so that would be -3. And that's our formula for the line tangent to the graph at x equals -2. So that's a little bit of work with problems that involve finding the slopes of lines tangent to functions. My name is Larry. I'm a teacher at EdVisions off campus. It's an online project-based school in Minnesota. If you're interested, you can find us on the web at lovethisSchool.org. Thanks.